Good morning, Abhishek Srivastava, sir.
Good morning, madam.
Good morning to all the participants. Now, I feel privileged to welcome Dr. Abhishek Srivastava as our next speaker for this session. Dr. Srivastava is an Associate Professor of Digital Marketing and Technology and Associate Dean at Faculty of Management Studies at GNS University, Rohtas, India. Dr. Srivastava is an acclaimed digital marketing analyst and technologist and has published more than 50 journal articles, book chapters, technical reports, as well as many conference proceedings. His research areas includes digital market associations, applications, social media, marketing, and management. With total 15 plus years of experience, having 3 PG degrees in one in commerce, 2 in computers, along with his PhD degree in the area of e-commerce. He is also heading the Department of Information Technology at Gopal, Narayan University since 2018. So I welcome you, sir. Please proceed with your session.
Thank you, madam. Thank you for this wonderful introduction about me. Thanks a lot. It's our culture and tradition that, let me share my desktop first. And I hope I am audible. I am audible to all of you.
Yes, sir.
Okay. So it's a culture and the tradition of our Indian mythology that we should start our any of the thing with the worship of God. But today I'm not going to start with the worship of God, but I am going to start with the Sanskrit sloka, that is Aneka Sanchayo Chedi Paruksharthasya Darshakam Sarvasya Lochanam Sastram Yasya Nastadhim Evasa. The meaning of this particular sloka is very like contemporary to the present environment. Like it blasts many doubts, foresees what is not obvious. Science is the eye of everyone. One who hasn't got it, it's like a blind. So science is everything. Nowadays, we have to believe that everything is there, and ultimately we need to focus on the thing which is associated with this part. So it is like today I'm going to deliver this topic on this driving business values through Industry 4.0 and Digital Twin. Somehow we need to connect it. I have gone through the lectures which you have actually like you guys have learned here in the FDP, 5 days FDP, but somehow I have find a unique way to explain you about this industry 4.0 in association with the IoT part and the part which has been very much near to all of us, like digital twin. So whenever we are asking, like now we have to switch from IPv4 to IPv6, believe me, we cannot imagine the number of internet components or the machines or the devices that we are going to club them together. And IPv4 was obviously not able to adjust or to manage all such devices at a time, and therefore we need to introduce this IPv4 technique. And nowadays it has been witnessed like, yes, this is the ultimate need for IPv4. Coming to the point of this working of IoT, I'm starting with this particular deliberation with the IoT part. Like right from the morning when our alarm goes on, then automatically our curtains may open up. Like coffee machine may initiate and prepare a cup of coffee for the persons. Then the geyser, which may automatically starts and prepare for you, like if you are willing to take your bath at sharp at 7 a.m. in the morning, then it will be automatically started. So these are the things which is very much interconnected, just because we are following our routine, and everyone should follow. So if we are in a routine, why not to have a batch process sort of thing in terms of IoT. And although all of this is fascinating, so lot of things are going on in background and nobody is going to bother like what are things which is being associated with the present issue or the past or the upcoming issues. And therefore for seamless functioning, we need to focus on the part which is associated, which is closely associated with IoT. So I am today here to discuss about all such things like IoT plus Industry 4.0 plus your digital twin. So there is a close proximity or the connection between IoT and the Industry 4.0 along with the digital twin in association with the AI part. So AI is something like everything, machine learning, AI, IoT, and they are together leading to the development of Industry 4.0, which is the utmost need of our society. डिजिटल इंडिया की बात हम करते हैं, बट डिजिटल इंडिया कैसे बनेगी, nobody is going to bother. We are working in a manner like we have to actually initiate such a thing, initiate in such a way so that Industry 4.0 can be like optimized and can be like it can be in a vein of our country. So this is what something like, as we all are knowing, like IoT devices are there. There are two types of devices: general devices, sensing devices, and we have to focus on all the three. The first example which I have given to you, this is the general device example, like making on your AC, then your geyser, TV, alarm, coffee machine. Even you can control the lights of your houses with the help of your remote devices, remote mobile phone applications, and all of them are clubbing together from the cloud. Can somebody unmute their mic? Can somebody unmute their mic? Okay. So the thing is, we have to focus on these all things just because we need a smart city, we need a smart nation, and that's why we have to integrate this IoT device with like we have another part. General, apart from the general devices, we also have the sensing devices. So sensors, smart sensors like humidity sensor, temperature sensors, smoke sensors, and a number of sensors are there along with the mechanical arms, digital arms. So they are actually working together, and along with the general devices and the sensing devices, we are creating a smart world or the smart nation. So it is like if we are going for the thing, I think my PPT is visible to all of you. If working of IoT, if literally we are asking like if suppose there is a farm and we need to know that what is the temperature of that particular garden or the farm, and on the basis of the temperature the fountain may activate and the water may goes out, just because to nourish or to nurture the quality of farming inside that particular field. So we have to keep a close watch on the humidity part. So for that, we can actually activate a number of sensors there, and without lacking or without taking so much of time, the sensor may advise us like what should be the next part, and IoT may run on the basis of the same. And on the basis of these all sensors, actually we can activate any of the thing from anywhere across the country, across the world. So IoT can actually feed Industry 4.0 too, just because from Internet of Things we can exceed for Internet of Everything. So adding the smart word like smart production, smart manufacturing, smart industry, smart factory, like we can actually making everything smart. So IoT refers to the billion of physical devices around the world that are now connected to the internet, and all collecting and sharing data are the same thing that we need to understand, that we need to optimize, that we need to analyze. And therefore, thank you for arrival of this super cheap computers and the ubiquity of your wireless networks, it is possible to turn everything from something as small as a pill to something as big as an aeroplane into a part of the IoT. So together we are integrating everything, and we are now actually we are moving for the smart smart manufacturing, from the smart industry part, from the smart like controlling of everything. As a manufacturer, we expect the extra value of Industry 4.0 as well, as the world is experiencing digital transformation. Studies have proved that potential of the Internet of Things has reduced cost, improving efficiency, quality, and achieving data-oriented predictive maintenance services are there, just because collecting a wide range of real-time data is something which is the utmost requirement of today's. And for collecting, we need to understand the product as well as the environment factors. And for that, we need to go for the smart sensors, reliable communication network, then your seamless integration. IoT as a critical industry 4.0, that is enabler of your emerging smartphone applications for higher customer satisfaction. So something is like establishing factories with the limited resources are facing challenge, and to change the long-standing production lines and meet customers' requirement is the most important thing. A technical analysis as per the Gartner predicts that the enterprise and automotive sectors will account for 5.8 billion devices this year, up to which almost like utilities will be highest users of IoT. And thank you to continuing rollout of smart meters, security devices in the form of intruder detection, and the web cameras will be the second biggest use of IoT devices. We never have think of it that in the past, like a couple of years back, we can't think that we are going to integrate each and everything on a smarter part, on a part of like internet connection. But yes, we are doing it, and right from the light, right from the sensors, right from the smart connected cars, internet connected cars, even healthcare units are there, those who are monitoring chronic conditions. We are now getting ourselves enable this particular IoT. And now, believe me, IoT is all about data. Whatsoever we are facing, just because we are going to accumulate the data from the environment, and what it impacts, it refers to the system of interrelated, interconnected objects that are able to collect and transfer data over a wireless network without human intervention. And today's business are moving like they are getting motivated by the IoT part, and obviously from the prospect of improving or increasing the revenue part, that is reducing, or obviously they are going to reduce the operating cost as well and improving efficiencies. Now the business also are driven for the need for regulatory compliances. Regardless of the reason, IoT device deploys data and insight, they are streamlining workflows, visualize uses patterns, automate processes, meet compliance requirement, and complete more effectively and efficiently in a changing business environment. And now the issue is like why IoT is getting more stronger and bigger. This is just because we are enhancing with the network, because it makes connected cities safer, assets tracking more cost effective, healthcare more personalized, and energy consumptions are more efficient. And that's why we need to understand the situation, and obviously on the basis of the situation we are analyzing the content. Businesses that are harness that the data generation from the IoT part will survive and thrive in the future. They will realize a significant competitive advantage. Just because we are getting into it, we are excluding lots of data from it, and that's why it is the utmost requirement of today's. Now come to the part that is very much associated with IoT, that is your Industry 4.0. We must have understand like what is Industry 4.0. Our planet has more connected devices than people now. You must be knowing the IoT will transform the way businesses, government, and human interact with the rest of the connected world, and that's why we need to integrate with the industry part. So even like we are moving from the smart home to the smart watch to the smart car to the smart farming to the smart retail, smart warehouse, smart city, smart health. Everything is there. Everything is there. So if we are willing to make this particular smart city as well as a nation with such smart gadgets and devices, future of IT becomes more promising. And this is what the requirement. Now you must have heard if we are taking in association, like in 2018, 23 billion devices were there across the world, those who are connected with internet. This is like more than even twice of the total population. But in 2025, it has now we are predicting that almost 80 billion devices will be there to get interconnected with each other in 2025. So what we are actually expecting from IoT, what we are expecting from the smartness of this IoT as well as integration of IoT from the industry 4.0. So IoT is supposed to be the vision to connect all devices with the power of internet. And obviously we need always learning and always growing sort of thing is there. So we are actually going for a revolutionary change in our entire universe. So as per the industry revolution is concerned, you must have observed from the first revolution that starts in that was started in year 1770s, like mechanization, water power, steam power system was there, and obviously those are not very much effective and we can say they are not very much promising. But somehow in latter stage, when we have moved from this industry 1 to industry 2, that is the mass production and the assembly line of the electricity, it is supposed to be the introduction of the assembly line is in a slaughterhouse even in 1870s. So electrification drives mass production in a variety of industries. And this was actually the revolution which was taken place in year almost like in 1870s. So it was industry 2. So coming part to the industry 3, where computer and automation will be there, was there. So development of the first programmable logic calculator controller in year 1969, and along with the growing applications of the electronics and IT to automate production processes. So we have actually started this industry 4.0 in year 1969 only, but the automation part has actually been converted from physical to cyber physical system. And this is what something which is the utmost we are in need of this particular revolution, and we have actually witnessed now in year 2011 itself, when increasing use of cyber physical system was there. And in January 2011, industry 4.0 was initiated as a future project by the German federal government. It was the start of industry 4.0. With the introduction of IP, unlimited addressing space becomes available. And this is what we have talked earlier too. Like government, private companies, and industry associations have been focusing on industry 4.0 and making investments since 2010 even. So a paradigm shift is there, which made possible, like we have everything is there. We have everything in industry 4.0. In industry 4.0, we have everything to witness, and that's why what we are opting is like we made possible by technological advancement, which constitutes a reversal of conventional production processes, like logically. Actually, by the logic we have actually changed, but somehow on ground level we need to work hard. And simply put, this means that industry production machinery no longer simply a process, and the product communicates with the machinery to tell exactly what to do. So this is what the revolution, this is what the requirement, and nowadays we are working on it, and we are actually witnessing the same. Ultimately, we can say like the value of industry 4.0 concept can be enhanced through a clarification of the role played by the technologies that facilitates the physical manipulation of object. So connectivity, information, and action. These three things are there, which is like information, value loop, and industry 4.0. They are creating the thing. So this is what we are asking. If we can observe this particular slide, this industry 4.0 is comprises of like cyber security, cloud computing, mobile technology, machine to machine, 3D printing, advanced robotics, big data analytics, Internet of Things, RFID, cognitive computing. All together can be clubbed so that we can achieve the target of this industry 4.0. So itself industry 4.0 is nothing just because we have integrated all essential components of our advanced computing, and then that's why only we can ask like, yes, industry 4.0 is playing a vital role just because of integration of all these activities, all these digital benchmarking together. So it is a leap from digital back to the physical, from connected digital technologies to the creation of the physical object. That constitutes the essence of the industry 4.0 concept. The IoT is a crucial, perhaps the most crucial element of industry 4.0. The IoT concept has gained tradition, like they are with the recent, in connection with the recent year, as per the importance of connectivity, both of the creating products as well as services and increasing satisfaction among customers and clients. So actually, we are now looking for the advancement in the form of like high performance computing, high quality sensors, more reliable and more powerful network, robotics, artificial intelligence, cognitive and augmented reality that can be taken together, and these technologies can change manufacturing in the profound way. Our analysis of the result, like flow of information, motivates a framework that captures the series of sequence of activities through which organizations create value from information. The IoT is the most important thing is there, and that's why we are focusing on this IoT part as an inevitable part, just because industry 4.0 is witnessing industry 4.0 is witnessing a major change just because of these integration technologies. So I think we can share this. If you can look at this particular slide, initially the connectivity is there, that is implementing basic level of data collection, analysis, and the communication part is there. So we have actually like three horizons of industry 4.0: implementation and usage. So one is your process optimization, that is increasing networking and digitization, improving current processes and optimize use of assets, increasing automation and upgrading other standards to reduce cost, and then maximizing data collected and leveraging data with the advanced algorithms. You must be knowing all these just because this is the optimization. This is the first and the foremost part of our industry 4.0 initiation or the implementation. Later on, if we are moving for the second point, that is process flow and quality, creating digital thread throughout the entire process, from sourcing of raw materials through post scales, implementing new cybersecurity measures to address risk of increased connectivity. That is like we are flowing, we are actually managing the flow control. So, and another thing that is the third and the most important thing is new business models. We have to implement the new business model, just because for every sort of thing, for every sort of connection, we have to improve our model for the betterment of the existing one. So using the collected data and insights to create new revenue streams and the value of customers. So building new products based on the insights digitally gathered from the clients. So we are here to witness. Again, the operation part, the first part, that is we are going for that horizon part is their operations optimization. It is the new way to increase. New way means what? We are actually focused on predictive maintenance first of all, just because we should know that which particular part of our machine is going to be is going to face some wear and tear sort of thing, and that's why we need a corrective measure on a preventive maintenance and solution that decreases unplanned downtime. So downtime is there, but if there is an unplanned downtime, we need to focus on that particular part. We can replace, so that we can easily replace the content. We can easily replace the component of that particular machine. Then the robotics is there. Obviously, advanced machinery to complex task automation, robotics is required, and we are focusing on it. Additive manufacturing like 3D printing and the surrounding ecosystems are there. Then the safety, obviously, worker safety is the utmost requirement of the organization, of the workshop, of the industry, and that's why safety is the most important factor of industry 4.0. And we are we are intruding this particular thing in our system just because it is the very much we have to focus on it. Inspection and testing is another part that we need to go, or we need to run this module for every time so that the plant can run throughout and without having any hazard or difficulty. Then the second part, that is the horizon second two, like it started with this cyber security part, then the sensing and the imaging, then IoT platform and the connectivity, then the supply chain. Most important thing is supply chain here, just because you can understand the cyber security and the sensing part, but supply chain is something like whenever we are lacking with lots of things when we are going for the production. So supply chain is something like we have to increase the visibility, or we have to maintain the threshold. We have to maintain the bucket of the raw materials, as well as reorder quantity should also be maintained together. And for all these things, supply chain is the most appropriate version that is need to be discussed. Improved predictability that provides company with a significant cost, as well as saving of eliminate opportunities to for the revenue generation or the growth of revenues. Obviously, supply chain, if we manage to handle the supply chain, this entire system, we can make a big profit just because of maintaining all such things or managing all such things with the help of this smart part, IoT part. So future key focuses on many manufacturers, and that's why, so leveraging of data and integrated solutions into the production, that leads to the third version. The third version is there, and obviously now what I have discussed it, we need to analyze the data. There is a part that is the part of artificial intelligence, along with the new technologies, that is interaction machinery, integrating machinery together so that one component can be connected with other component, and together they can have a seamless connectivity, they can have a synchronization part, and the new form of human machine interaction such as bots and augmented reality systems will be there. So improvement of transferring digital instructions to the physical world via advanced robotics and 3D printing will be there, and that will lead to the generation of this industry 4.0 in a very effective manner. So altogether, it is like what we can say. The industry 4.0 is the part which is need to be augmented, which is need to be implemented with the help of all these smart components together. So see, from physical to digital, this is what the essence. So from physical to distance, if the product is impacted, now the potential of IoT applications will be like sensors and control, wearables, augmented reality. Again, when we are talking about the digital one, signal aggregations, optimization and predictions, visualization, and like cognitive and high performance computing will be there. And then from again converting from digital to physical, that additive manufacturing, advanced materials, autonomous robotics, digital design and simulation part will be there. So potential is there, undoubtedly, like making already existing products smarter. How can we make? Just because of adding sensors, connectivity to improve productions, performances, enable connections to mobile applications to improve the user experience, and to add advances like materials to existing product to improve performances. Then offering the data generated from smart technologies as a part of the service, just because we have the previous gathered data, and on the basis of those data we can predict something, we can assure someone like whatsoever the data is there, the quality of the data is there, we can offer you some better option. So offering of access to the data and the metadata generated through existing business operations, like building and selling of a platform on which to manage data from connected products, enterprises, develop tailored data bundles and individual data, end users data. So offering is something like just because it's a prediction. So based on the previous data, we are predicting a number of things together. So developing completely new products and services, like developing cost-effective mass customization, enable new and hybrid product innovation through advanced manufacturing technologies, that is creating a new service formats and the business models, obviously. So these are the things which is like we can discuss The most important part now, which we need to understand, like what is the digital twin and why we are also focusing on the digital twin in association with Industry 4.0. So digital twin is a digital representative, basically we can say, that can define fundamentally as evolving digital profile of the historical and current behavior of a physical object or process that helps to optimize business performances. It is actually for fun as well as double the possibilities as well. So whenever we are looking for the IoT endpoints, here I am discussing even. So the representation of physical objects, processes or services or digital twin can be a digital replica even for the objects. So it is the most important part of the physical world, just because like whenever we are asking about the jet engine, suppose, or wind farms, or even larger items such as buildings or even whole cities, don't you think like we can have a digital twin model and we can implement all such things together on that particular digital twin model, and later on we'll be like converting that digital twin into the reality, into the augmented reality part. The digital twin is essence of computer program. So why we are actually using this digital twin or how it is working? This is the most important question as well. So I think I can play a video for you all. Just wait.
Abhishek sir sharing.
Just I'm sharing this digital twin YouTube. Just wait. Yeah.
Okay, sure sir.
Visible to you? Yeah.
Yeah. Yeah.
Audio is there? Audio is there? Yeah.
Sir, no audio.
No audio?
No sir.
Okay. Okay.
Sir, please
Wait.
share it in application window.
Okay. Okay.
Sir, please share it using application window. Then the voice will be.
All right. All right. I'm sharing it. I've given it to you. I think there is a problem. I don't know why it is not voice is coming, as well as just wait.
Sir, are you sharing in application window or desktop?
I'm
Because
I'm sharing with yeah. I'm sharing with the this Chrome window.
okay.
Yeah, with the Chrome window. I don't think it is applicable here, just because voice is not coming. So
Sir, use Internet Explorer. It will show sir. Voice will be.
okay. Wait. Okay, so I think it will work. Just wait.
Okay, participants can take a 5
Yes,
minute break.
yes. I think it is working. I think it is working now.
Okay, okay, sir.
Audible? Voice is coming, I think.
No, sir, voice is not coming.
Shall I share it with you? You can like present from there.
Sir, send me. Okay, send me the link, sir.
Yeah, yeah. I'm sending you the link. You please just play this. Yeah. Yeah, I have shared it with you, Manishi. Please play it. Have you received?
Yes, sir, I received. Just, just a minute, sir.
Okay, okay, okay. Sorry.
Voice is coming, sir.
No. Even the video is also not visible.
Video is coming, sir.
Yes, yes. Now the video is coming. Please
And
start it from
voice,
there. Yeah.
sir.
Restart.
Voice, sir.
No, voice is not coming.
Okay, sir, can we skip it?
Yeah, I think so.
Okay.
I think so.
Okay, okay.
Better I
Okay, sir.
make you understand that. No worries. No
Okay,
worries.
sir.
Now, the thing is, the digital twin is supposed to be the life of digital twin. Unfortunately, the video that cannot be played here explains a lot about how we can play with digital twin. So, artificial intelligence, machine learning, and analytics is the combination, is the deadly combination, and that's why we can call it as digital twins. So the life of digital twin begins with the experts in applied mathematics or the data sciences researching the physical and operational data. The developers who create digital twin ensures that the virtual computer model can receive feedback from the sensors from that can gather actually data from there from the real world, then lets that digital version mimic and simulate what is happening with the original version. You can see here, just have a look. Yeah, this is what something we can say. This is what the digital twin manufacturing of digital twin model is there. So before starting with the digital twin, we need to have a prototype. This is that is undertaken before a physical product is created. So we need to develop a prototype. After that, we need to develop the instance of it, that is DTI, that is done once a product is manufactured in order to run test on different user scenario. So scenario is something like we have to create the scenario building, and after scenario, we can actually aggregate the data. So digital twin aggregation is there, like we are gathering DTI information to determine the capabilities of the product as well as to run the prognostics and the test operating parameters. So parameters, whatsoever parameters, maybe once we have to develop that prototype, and after that we need to focus on the different parts. Here in this particular slide, you can easily see that we are like creating, communicating, and acting with the physical in association with the digital, like aggregation, analysis, and the insight. These three parts, that is data, digital, and analytics, together they can be clubbed and they can actually integrate so that we can create a digital version of the physical one. So physically, we have the sensors, physically we have the actuators, we have the action part, and logically, or you can say the virtual part should be like whenever we are going to integrate it, we should have appropriate amount of data as well as the analytics part that we need to understand, that we need to focus on it. So data and the modeling part is like something which we can AI is supposed to be the most important and the most powerful combo for these particular thing. So data, the modeling part, the linking, these three things are there, which with the help of which we can say that yes, we are understanding digital twin, we are understanding the benefits of digital twin, even like they are differs with the depending and where and what. For example, like using digital twin to monitor existing products such as wind turbine or oil pipelines can reduce maintenance burdens and save many millions in association with the cost even. Digital twins can also be used for prototyping ahead of manufacturers, reducing product defects. For example, we can create a twin of a motor. So whatsoever the functionality of that motor will be there, we can just analyze the functionality as well as pros and cons of that particular motor just by creating a mirror image of it. So it's a mirror image actually, but with all the functionalities. So digital twin can actually, like अभी हम लोग जो predictive model की बात कर रहे थे, so predictive model में भी क्या है, digital twin is playing a lot role, क्योंकि physically it is not possible at all for every aspect. Like car crashing test जो होते हैं, there also we are having this digital twin model nowadays, just because we can add a number of sensors, we can add a miniature model, we can add a virtual model, and now on the basis of those model, on the basis of those functionalities of the sensors as well as the smart capturing devices, we can create a virtual model, and now we can test it like the physical. And this is what the ultimate solution for this digital twin. So common benefits may increase with the help of reliability and availability through monitoring and simulation to improve performances as well. So they can also reduce risk of accidents and unplanned downtime through failures, lower maintenance. Obviously, maintenance costs will be reduced just because we have to go for the virtual one and not the physical one. So maintenance cost should predict the failure, maintenance, repair, and ordering or the reordering of the replaceable parts too. So they can be automatically reordered just because they are knowing that this particular task is now, this particular part is now going to get failed. And before it get fails, it can be reordered. And obviously we are somehow managing the supply chain management too with it. So digital twin can also offer continued improvement with the analysis of this customization model, and it also ensures like product quality through performance testing in the real time. Now the big question is where we are going to implement this particular digital twin technology. So there are a number, or you can say a variety of like fields where we are using, or we can actually predict this particular digital twin model so that to achieve this industry 4.0 objective. So manufacturing is there, the field manufacturing, in which digital twin can make manufacturing more productive and streamlined while reducing the throughput times. Then automotive part is there. I can give you an example like where digital twins are used in automotive industries to gather and analyze operational data where vehicle in order to assess the status of the real time and to inform product improvements. So instead of wasting time on here and there, we can go for this digital twin model for every sort of thing. Then obviously in the form of retail, outside of manufacturing industry, digital twin is used in retail sectors for the model and for the augmented reality for the customer's experience, even where all the level at the level of like shopping centers or the individual stores, we can have this digital twin model so that one can analyze the requirement as well as the opportunities that we are not getting while having physical. So we can go for the digital one. In even the most important part that is digital twin is going to play in the healthcare sector. The medical sector has benefited from digital twin in the area like organ donation, surgery training, and de-risking of procedures. Like systems that have modeled the flow of people through hospitals and track where infections may exist and who may be the danger through contact. So these are the things that can be actually transformed from physical to digital. Again, there is a part like disaster management. What should be the task of disaster management? Global climate change that has impacted across the world in the recent years, that can actually be handled successfully by the help of this digital twin model, which can help to combat this in the section like it can inform creation of smarter infrastructures, emergency response system activation, planning, and obviously climate change monitoring even. So we have even whenever we are talking about industry 4.0, we should also have to focus on smart cities. So smart cities like digital twin, that is going to obviously make a smart city smarter, just because we are having more economical and environmental and societal sustainability. Like virtual models can guide planning decisions and offer solutions on the most complex challenges faced by the modern cities. Even we have already implemented, I think in the Hyderabad, some sort of roads were there, those who are equipped with this technology along with the IoT part, where they have put sensors there, and at every kilometer or every 2 kilometers they have put this sensors on the 6-lane or 8-lane highways, and they are monitoring the speed of the vehicle, and the moment they are getting that like the speed of vehicle is now decreasing or decrementing, it means like there is some hurdle or some obstacle or some traffic will be there. So they are transforming all such information to the user's mobile, to the user's display, even huge display units were being installed, and they can actually observe users, those who are commuters, those who are commuting on those roads, they can on the real time scenario, they can actually view like what is happening in the next 10, 12 or 15 kilometers ahead, and that's why they can take the appropriate diversion for the scene. So we are now implementing all such things together. Today companies are using digital twin capabilities in variety of ways. In the automotive and aircraft sector, they are becoming essential, like tools for optimization entire manufacturing value chain and innovating new products and services. In the energy sector, oil field services are there, then that can actually create a value chain. And most important thing is like in the recent market research, it can also be said that already underway that digital twin market worth US billion dollar 3.8 in 2019 and is projected to reach around 35.8 billion in 2025. So almost like 10 times of increase in this digital twin model in the upcoming 4, 5, or 6 years. So people are now readily available, are readily taking these all initiatives, or like what we can say, this particular digital twin technology, just because they are knowing the benefits of it. So digital twin is now trending and gaining momentum, thankfully to rapidly evolving simulation and modeling capabilities. So better interoperability and the IoT sensors and the more availability of the tools as well as the computing infrastructures even. As a result, digital twinning capabilities are more accessible to the organization. So they are something like they are irrespective of the size of the organization, like from large to small or from across the industry. Digital twin model is now going to get a huge round of applause from the industry, correct? And 40% of IT platform vendors will integrate simulation platforms in systems and capabilities to create digital twin, with 70% of manufacturers using this technology even to conduct like process simulation and scenario evaluation. So at the same time, what we can say, like digital twin is getting more smarter and smarter just because of the instances. Like we are having a number of examples. If we are going to quote here, uh, like in the automotive industry, suppose what just wait, yeah. So if we are going to have the example of digital twin, we can say that it helps personnel to get comfortable with the internet of things implementation, and obviously automation, because they have the opportunity to simulate the application prior to going live. So the lessons learned and the opportunities uncovered through a digital twin can there to apply to the physical environment. For example, there are certain instances where digital twin is using for airspace also, like engineering, engine monitoring. Engine monitoring is something like today is the most important part, is like digital twin in aerospace industry is acknowledged just because the experts are saying like 75% of air forces executives have cast the vote for the confidence in favor of the digital twin, and just because they know the implementation aspect of this digital twin, and without having, just because there is no second chance in aerospace modeling, as well as in case of getting fatal accidents are there, no one is going to survive, and that's why digital twin model is going to get a more bigger benefit for them. So with the digital twin, engineers can actually use predictive analysis. They can foresee any future implications, problems involving for airframes, engines, or like other components, to ensure that the safety of the people on board is the utmost priority of aviation industry. So they are something like they are working on it, and they are doing the same thing. Like for example, that the Air Force is having difficulty predicting the average lifespan of the jet engine, or the forecasting of the potential risk or not performing essential plane engines replacement procedure, in order to figure out how long pilots can use an aircraft safely. So if pilot is now going to board the plane, they should know the basic parameters of that particular engine and the performance of the engine, as well as the downtime of the engine, like when and what time it can get some defects, or like some, so potential risk can be exposed. By creating a digital twin of an aircraft engine, it is like pilot can have the ability to monitor engines health and progress of the simulation. 10 at, for example, say for if their flight is for 9 hours or 8 hours, they can have a simulation of for 10 hours, so that they can understand that during a flight what can happen, what will be the pros and cons for that particular flight, and in order to see the potential risk of the engine experiencing a fatal failure in the near future. So they are working on the same. Applying digital twin technology on city infrastructure, another important thing, in order to improve the transportation and the travel systems in New York City, for example, the government have decided to create initiative and build a digital replica for the city itself. Yes, they are doing. By building out an entire city on a digital platform, engineers are now able to develop digital road systems, like underground and accurately predict how it transportation facility or the system is working and how it can incorporate itself for the normal road of that particular city. Finally, by having data on the average deterioration rate of the road is one of the biggest, or you can say the busiest street of the city, and that's why they are able to make safe predictions on how often the new underground roads will need to be replaced in order to ensure the security of the new road system. So it has already been implemented there, but somehow we are getting data, and like data is something like which is very much now important. Again, we have product development. Digital twin can help engineers test feasibility of upcoming product before launching, or according to the test results, they can start producing the same or shift their focus on creating a feasible product even just because they have the appropriate model to design. Again, from the customization with digital twin, businesses can design various pre-mutations of the product so that they can offer personalized products and services to their customers. Then shop floor performance improvement, something like digital twin can be used to monitor and analyze end products and help engineers to see what products are defected and has lower performance than intended. Self-driving is something like which is Tesla is now getting more popular just because of their driverless cars. So what do you think? They are having this digital twin model before it's implemented. It reduces manufacturing industry.
Hello,
Automate the
Abhishek sir.
system.
Hello, Abhishek. Sir, your voice is not clear. I
Oh,
think there is a technical problem. Your voice is not clear, sir.
wait. Am I audible now?
Yes, sir, you are audible, but your voice is not clear, sir.
Okay, let me change the network. Let me change the network. Just
Okay, sir.
Am I
Yes, sir, you
audible
are
now?
audible. Yes, you are audible.
Okay. So, so I was actually discussing about this self-driving car development through digital twin. So later on, I have discussed just because of this digital twin model, even Tesla company has actually released their driverless car. And though digital twin practices has been actually like from traditional automotive manufacturing industry to the digital twin, that they are going to get autonomous vehicle companies. So self-driving car contains numerous sensors, and they are actually collecting data from all sides of that particular car, and the vehicle itself is and the environment of the car is now they are getting ready for any sort of action that can actually be communicated to the car, to the engine of the car, and due to the liability that is that surrounds autonomous vehicles, creating a digital twin of the car and testing every aspect of vehicles, is helping companies to ensure unexpected damage and injuries, which has been actually minimized just because of these interconnectivity of the technological issues. Some applications of digital twin in the automotive industries are road testing as well as vehicle maintenance too. They are now getting converted. Actually, they are getting so much of like tools and tactics that they are now equipped with full of sensors at every stage of their development, and now every particular part of that particular vehicle is now getting connected with internet, is now getting connected with the service centers, and for any sort of maintenance required for that particular component, they have actually initiated their like a recovery, or you can say a repairing of that particular thing or replacement of that particular thing. So we are having ample amount of like this issuance of this digital twin, like optimizing warehouse, even optimizing warehouse and the operational performances of this technique can be done with the help of this digital twin that enables logistics companies to test warehouse layouts. So companies can choose the most important or the efficient warehouse design to maximize the operational performances. Creating a logistic network, obviously we have discussed, like whenever we are going for the supply chain management, we can create a logistics network, and logistics network without having a digital twin model is like nothing. Just because we should create the traffic simulation or the situation, the road layout and the construction part, you must have observed that huge sometimes used machinery has been loaded to the trucks, and that can be commuted from one place to another by the from road even. So we can actually create a simulation of those roads, and where we can get the obstacles, we can actually analyze the same. So these are certain things that can actually create the logistics network, and obviously there are logistics companies, those who are actually started designing their distribution routes and the inventory storage locations with the help of digital twin model. So even customers like even construction is there. Even construction in digital twin, we have construction firms understanding like how a building is performing in real time, how building is performing in the case of earthquake is there, in the case of flood is there, in the case of any natural calamity is there, even in the bomb blast or at some unexpected like part is there, they can actually allow them to tweak performances to optimize efficiency. Data collected from digital twin can use for planning and designing future buildings too. So now these are certain things that we have discussed. As far as now even I can discuss you one more thing. Even at the Spring Festival Gala, China Central Television, the 4 human hosts were joined by an AI copy of themselves. They were very much like own, they have created their own digital twin that has been created by Oben. So they are more than the computer generated avatars, because they uses machine learning, natural language processing and the computer vision, and that builds virtual copies of the host even. So future applications for these technologies includes plan to build AI powered teachers, nurses, doctors. So ultimately, no one is going to teach us just because we have created our own digital twin, and now everything that has been replicated, it can like we can do whatsoever that has been instructed, or on the basis of the twinning model we are working here, and our digital model is working at some other location. Just because this digital twin model, even smart city like Singapore has this digital twin of Singapore. They have imagined all the variables that go into the management of a city. Digital twin technology helps city planners even to understand and improve the efficiency of the energy consumptions, as well as many applications that can improve life for their citizens too. So somehow what we can say, so the digital twin is like a boon for everyone, just to handle it in a very in a very effective manner even. So as per this diagram, this benefit of digital twin is concerned, it has to improve the quality and the yield. It should increase the efficiency of the engineer. It reduces the cycle time and the boost productivity. It has diagnose and the fix failures feature also, optimizing robot operations management, reducing operational cost. So these are the digital twin, and the future is almost ours. So in future, expect to see that expansion of IoT, and with some version of digital twin technology, as per the predictions, 95% of all IoT platforms will include some kind of digital twin. So whatsoever we are today, definitely in year 2025, we'll be having more difficult, more different, more innovative ideas. Will be equipped with more ideas will be there. So this is all from my side. If you have any doubt, you please ask. Thank you.
Okay, participants, if you want to ask any question, just raise your hand. I will unmute. Anyone want to ask any question? Okay, Abhishek sir, we will mail you the question, and I think you will. Yes, sir. Okay, sir.
Right. Thank you.
Thank you, Professor Abhishek Srivastava, sir, for your valuable session. We learn a lot and understand the concept of driving business value through Industry 4.0 and digital twin and AI-based approach. We also learn how these technology can be implemented in the industry, benefit of digital twin with example, and many more. Thanks a lot, sir.
Thank you, sir. Thank you for inviting me there. Thanks to all the participants and for their patience listening as well. Thank you.
Participants, please fill the feedback form. Okay, thank you, sir.
Thank you. Thank you.
फीडबैक फॉर्म चैट बॉक्स में नहीं डाला आपने?
Yeah, you can see.
अच्छा, ठीक है, थैंक यू.
Current session was the FDP session number 7. You can see the feedback form session number 7 in the chat box.
Sir, chat box not appearing.
Okay, I am pasting in WhatsApp group also.
Thank you, sir. So we can leave? Manish sir, so we can leave?